Today we are going to start Physics Module 3 Superconductivity. What is superconductivity? Let us first define, and after that I will give you the examples related to it. Superconductivity means the phenomenon in which electrical resistance of certain metal it may be metals or alloys, or it may be any compounds drops to zero, which means when the resistance it drops to zero abruptly or suddenly drops to zero below a certain temperature is called superconductivity. See, let us first understand this definition. The phenomenon in which electrical resistance of certain metal, alloys or compounds drops to zero. Suppose this is a metal, and when we supply the electric current to this metal, if the resistance of this material is zero, then this material is said to be the superconducting material, and this phenomena is known as superconductivity. Suppose you are playing in a playground. Imagine a playground you are playing. Suppose you are playing cricket. There is no person to stop you. You are free to play the cricket anywhere, anytime, and how you want. You are an electron. You are playing cricket. Suppose the electron is moving. It moves freely. There is no one to stop the electron. Then this material is said to be a superconductor. There is no resistance inside it. Another example is, suppose you are moving in a highway. This is a highway. You are driving a car. If there is no traffic, you are the only person to travel in this road anywhere you want. Then you are free to move as fast as much you can. Raise the speed up to 100, 120 or 150. There is no person in front of you. You can consider while driving you must put the brake. So that speed is known as, this is a constant speed. There is no resistance to stop you. Next, another example is a cooling fan. Cooling fan is another example of this. Next, I think you have understood what is superconductivity. Next concept is zero resistance state. You know, the superconductors are said to be the best example of the zero resistance state because they don't have resistance by which the electrons can stop moving. Superconductors are the best example. Let us define zero resistance. resistance state. In short form we can write it as ZRS. Definition: it refers to a condition where a material or system conducts electricity with no energy loss. There is no loss of energy due to electrical resistance. Resistance. The best examples are superconductors, because in superconductors there is no resistance. Zero resistance means in the materials in which there is no resistance at all. Another example, the example is superconductor. Another example we can give it as a 2DES, which means two-dimensional electron system. It is another example of zero resistance state. Next, what is persistent current? Our next concept is persistent current. Persistent current means what? When a current of large magnitude is once induced in a superconducting ring, it means persistent. First of all, you know the definition of what is a persistent. Persist means unchanged or which continues, and tell it as which continues or unchanged. That is known as persist. Now, define it. This definition is important for the exam. When a current of large magnitude is once induced in a superconducting material, we can tell it as a ring. Superconducting ring. Once in a superconducting ring, consider a ring, then the current persist means you can write it as unchanged or continuous in the superconducting ring, even after the removal of the field. The current continues to flow. You have to describe with a diagram. This is a superconducting ring. Superconducting या फिर superconductivity means it has zero resistance. The superconducting ring means it has zero resistance, and these lines are known as magnetic flux lines. If these lines are magnetic flux lines, and this is a superconducting ring. What is the difference between magnetic field lines and the magnetic flux lines? Magnetic flux and magnetic field lines. If you know the answer, please comment, otherwise I will tell you. Magnetic field lines means magnetic field lines and magnetic flux. Suppose this is a magnet and the lines which are around it, these are magnetic field lines, and the area which is covered by these lines, they are known as magnetic flux lines. Let me tell you a simple example. Suppose in nature the air is present. The air, you can consider the air as a magnetic field lines, and the air which is passing through your window of your home, that is known as flux. Means how much amount of lines are passing through this area, that is refers to a flux, and the overall lines present in the magnetic outer surface of the magnet, those are referred as magnetic field lines. If you know some other difference, please comment. Okay. Our next concept is Meissner's effect. Meissner effect. What is Meissner effect? Let us first define this. What is it? Because it is important. This definition is asked many times. When a magnetic field is applied, to a superconducting specimen. By the way, do you know the meaning of specimen? At the temperature below critical temperature. What is critical temperature? The magnetic flux. What is it? Magnetic flux lines are expelled from the interior of superconductor. This phenomenon is called Meissner effect. Let us first tell me what is the specimen. Specimen means sample which you are using. It refers to that. Consider this is a specimen or a material inside which there is no magnetic field, and these are the magnetic field lines. These are called them as magnetic field lines. Another same material or a same sample in that the magnetic field is present and the magnetic field lines are shown in this way. What is the difference between the first figure and the second figure? Magnetic field lines are considered as all these lines, and magnetic flux is this much lines which are crossing this object or a sample. These are known as magnetic flux lines or magnetic flux. See, when a magnetic field is applied to a superconducting specimen, when we apply the magnetic field, here magnetic field is 0. When we apply the magnetic field at the temperature below critical temperature, the temperature below critical temperature, by this line you can write it here as this is the temperature. Here room temperature is greater than the critical temperature, and here critical temperature is greater than the room temperature. At the temperature below critical temperature, the magnetic flux lines are expelled from the interior. These lines are expelled means to. Expelled means what? Means it does not allow the lines to pass through the interior surface of a sample. As you can see, there are no lines crossing these sample, are expelled from the interior of superconductor. This phenomenon is called Meissner's effect. Here, the superconductor in normal state. Here, it is a superconducting state. Now, in the exam, they have asked it as explain Meissner's effect. You have wrote the definition of it, and you have explained it with the diagrams, and there are more some points which you have to write. First of all, let me know, do you know about magnetic susceptibility? What is magnetic susceptibility? What is the symbol which we use to denote the magnetic susceptibility of a superconductor? It is X. It is denoted by X. And what is the expression of magnetic susceptibility? The formula M divided by H. It is M by H. What is M and what is H? If you have written the CET exam in the first PUC or second PUC, you may know what is it. If you know the answer, then comment. It is a magnetization, and here H means magnetic field intensity. Magnetic field intensity. So magnetization means what? Magnetization means the magnetic dipole moment per unit volume. Dipole moment. What is dipole moment? Magnetic dipole moment per unit volume. So this is the basic. Now, what happens in the Meissner's effect is the magnetic susceptibility of a superconductor is negative. First of all, it is negative. Remember, it is the magnetic susceptibility. I can write it as X of a superconductor is always negative. This is the first point. And it is equal to 1. The magnetic susceptibility of a superconductor is negative and it is equal to 1. That is, magnetic susceptibility is equal to negative and equal to 1. Superconductor. In superconductor, the magnetic susceptibility is always negative and it is equal to -1. And the second point you have to write is Meissner's effect is reversible. Next, you have third point. You can write it as the magnetization vector. The magnetization vector, which is M above M, arrow mark, representation of vectors. It means magnetic dipole moment per unit volume. But it can be expressed in the following form. You have to use the same formula which we have used. What is magnetization vector? It is equal to the product of magnetic susceptibility and the magnetic field intensity. Now, from the first point, you have wrote it as magnetic susceptibility is negative and equal to 1 for a superconductor. For a superconductor, magnetic susceptibility is always equal to -1. Substitute in this, we can get M vector is equal to minus of magnetic field intensity, which means this magnetization in a superconductor is equal, and here we cannot say it as a negative because in vectors the negative sign indicates the direction. If this is x-axis, here we can write it at minus x-axis. It refers to the direction. It is in the forward direction, and the negative negative sign indicates it a backward direction. So you can conclude it that magnetization in a superconductor is equal and opposite to that of a magnetic field intensity. It is equal and opposite to that of magnetic field intensity. If the magnetization is in the forward direction, its intensity will be in the backward direction. You cannot say it as a negative because the negative sign here indicates the direction of the vectors.